Alright, welcome to part 2 of the video, which is the one where we're actually solving our first stoichiometry problem. So, this comes from question 6 in this sheet, the summary review sheet number 4. So this problem is asking, using the equation for problem 2 above, answer the following questions. So, if I do this reaction with 35 grams of C6H10 and 45 grams of oxygen, how many grams of carbon dioxide will be formed? So, I have my balance equation, which, if you recall, we have some steps on this, how to solve stoichiometry problems. The first thing is to do is balance the equation. Wow! The second thing we have to do is convert units of a given substance to moles. We could do that. The third step is to use our mole ratio to calculate the moles of a substance yielded by the reaction. And lastly is to convert the moles of wanted substance to desired units. So we can do that in some steps. The issue with stoichiometry, when you are not given exactly how much you're going to make, is that you have to do two problems. So when we first talked about stoichiometry, we talked about how if I have 1 pound of sugar and 3 pounds of flour, I could maybe make some cookies, right? We talked about pancakes in several classes, so let's talk about cookies. You know I like cookies. So I know that I need 1 pound of flour and half a pound of sugar, right? So I'm going to do an example on the side. If I have 1 pound of sugar and 2 pounds of flour, that's how much I have. I also have a recipe that tells me I need 1 pound of flour and 1/2 pound of sugar. That's my recipe. How many batches can I make? So this makes 1 batch. So because I have double my substance, I can make 2 batches, right? And this is giving you pretty whole numbers, maybe something we could relate to coefficients. But if instead of giving you large numbers like coefficients, if I were to give you grams, so if I were to say I have 500 grams of flour and 350 grams of sugar, well, we need to know what the conversion factor is for this, and that's what stoichiometry is. It's a way of baking some chemicals. Alright? So let's just keep this in mind. We'll work on this problem. We'll see how it works. Please do email me if you have some issues. I will try and resolve those issues as fast as I can. So let's start off. I need to convert my grams to moles so that I can use my ratio to solve this problem. The issue becomes, what do you want to make? Does the problem tell you? Yeah, it does. It tells you want to make CO2. So that's what I'm looking to make. And I want to make CO2 with this and with that. I have 2 different numbers I can work with so that I can get a good answer. And I want to make the best answer. So let's work it out. I need to find the mass of C6H10. I've done this. This is 82. I need to find the mass of O2. I've done this. That's 32. So we have 16 times 2, 32, and C6H10 equals 82. Alright. So the first thing I'm going to do is I'm going to convert these grams into moles. And I'm going to do C6H10 first. So C6H10, I have 35 grams of C6H10 in 1 mole of C6H10. I have 82 grams of C6H10. Then it tells me to use my ratio. Well, my ratio says that for every 2 moles of C6H10, I can make how many moles of CO2? I can make 12. So 12 moles of CO2 can be made for every 2 moles of C6H10. Remember, the coefficient here is your mole. So if you keep that in mind, it'll really help you out. The problem also wants me to do this in grams. Because it wants me to do it in grams, I should probably know the mass of CO2. So 32 plus 12, that is 44. So I'm going to convert this to 44. So for every 1 mole of CO2, I have 44 grams of CO2. So I'm going to run this through the calculator. That's a G, not a weird 5. So I'm going to do, here it is, 35 divided by 82 times 12 divided by 2 times 44. I can make about 112.68 grams of CO2. Okay, that sounds reasonable. I don't know what the answer should be, but that sounds about right. Alright, let's try it now with oxygen, with O2. I'm going to do that in a different color. So now I have 45 grams of oxygen. I need to convert, remember, these grams into moles. So in 1 mole of oxygen, I have 32 grams of oxygen. Now that I have moles, I can use my mole ratio. For every 17 moles of oxygen, and that 17 is coming from there, I can make 12 moles of CO2. And if you recall, 1 mole of CO2 has a mass of 44 grams of CO2. And that's a bit fast, but we'll get you there. So let's show you. 45 divided by 32 times 12 divided by 17 times 44 will equal 43.676, so about 43.68 grams of CO2. Alright, here's where the hardest part, if not the easiest part of the problem comes from. If I give you 35 grams of C6H10 and 45 grams of O2, both of these numbers are plausible insofar as the other one exists in excess. So that means that given 35 grams of C6H10, I can make 112 or about 113 grams of CO2. But that's only saying I can make this if I have enough oxygen. Oxygen, on the other hand, is only 45 grams. So because this number is the smallest number, I can only really make this many grams of CO2. That's called my limiting reactant. What limits me is the amount of oxygen I have, not the amount of C6H10. This is extra. I have extra C6H10. What I'm missing is O2, and because I'm missing O2, I can only make as much CO2 as the O2 allows me to make. So my answer is this. My limiting reagent is oxygen, because I don't have enough oxygen to make all of this CO2. I only have enough to make this much CO2. And that is stoichiometry.